Let's see now an example of how to discount future cash flows, i.e. coupons and par value, to present time in order to figure out the appropriate price of a bond. And let's use both the spot rates and the forward rates. And I will show you that those two methods will eventually yield the same result. So here is an example. Let's take an on-the-run debt issuance that has the following characteristics. 1 year maturity, the yield to maturity is 3.5% with a market price of $1,000. Par value is also $1,000. 2 years, yield to maturity is the following 4.2148% with the same market price and the same par value. 3 years, 4.7352%, and 4 years is 5.2706% with the same market price and the same par value of $1,000. Okay? These are the spot rates. The spot rates will help us to discount the future cash flows back to present time. In addition to that, let's assume that we also know the forward rates. Forward rates are taken from the futures and forward markets, and they're also quoted either on the internet or on newspapers on a daily basis. They can change, but usually they don't change that often. So let's see what are the forward rates. Pay attention, forward rates are future interest rates that are quoted for specific time periods, but then they start at specific points. So current 1 year forward rate is 3.5%, and it is identical to the same spot rate 1 year. It has to be because it's from present time for a 1 year period. The 1 year forward rate 1 year from today, meaning that this is the interest rate for 1 year, but this 1 year will start only 1 year from today. It's not going to start at present time. The forward rates in the forward market is quoted as 4.935%. This is slightly different than this, than the 2 years. Okay, over here you have the spot rate of 4.2148, and over here the 1 year forward rate 1 year from today is 4.935%. So pay attention to the differences. The forward rate, 1 year forward rate 2 years from now, which means that it will start 2 years from now, but it will last for 1 year, is 5.784%, and 1 year forward rate 3 years from now is 6.893%. Let's now price a bond or find a value today, the current value of a bond issued by the same issuer as the prior 4 bonds. In other words, it has the same risk as those yield to maturities for different time horizons, that is paying 6.5% coupon rate. Okay, $65 per year. Let's see how it is done in 2 methods. The first method will discount all the future cash flows using the spot rates. So the first coupon that is taking place a year from now, we need to discount it based on the first spot rate. So we'll divide it by 1 plus the spot rate, 1.035. That's the 3.5% interest rate, spot rate for the first year. And then the second coupon, $65, we're discounting it to present time. So we're dividing it by 1 plus the spot rate for 2 years square, because this is taking place in year number 2. The third coupon is $65, and then we're discounting it to present time by 1 plus the spot rate, which was 4.7352. And then everything to the power of 3, simply because this cash flow is taking place in year number 3. Finally, we're discounting the par value plus the last coupon, $1,000 plus $65, discounting it by 1 plus the spot rate in year number 4 to the power of 4. So altogether, if you'll do the math, you will get that the price of the bond, or the value of the bond right now, is $1,046.43. The second method will be to discount each and every cash flows using the forward rates. So the forward rates are quoted below in the denominator. Take a look at that. $65 first coupon, we're discounting it by 1 plus the forward rates, 1.035. Second coupon, $65, we're discounting it first by 1 year backward, so we're dividing it by 1 plus the forward rate for 1 year. That will take place 2 years from now. Once we're discounting it or dividing it by 1 plus these forward rates, then it's already located at year number 1, so we need to discount it 1 more year backward using the current forward rate, 1 plus the forward rate right now, which is 3.5%. So we're dividing it by 1.035. The same method we're going to apply to the third year coupon, which is also $65. So first we're dividing it by 1 plus the forward rate 1 year from today. I'm sorry, 1 year, but this forward rate will take place 3 years from today. The 5.784, here it is, 5.784. 1 year forward rate 2 years from today. So we're bringing it to 2 years. And then we're dividing it by 1 plus this forward rate, 4.935, which is the forward rate for 1 year from today. Here it is, 4.935. And finally, once it is located 1 year from today, we're dividing it by 1 plus the forward rate from today, the 3.5%. So altogether, we're creating the present value of this cash flow. Same thing we're applying to the forward rate at year number 3, the par value and the coupon, which is 1,065. We're discounting it by each and every forward rates until we're bringing it to present time. If you'll do all of this math, you will see that the valuation is identical to the spot rates, also $1,046.43. So the concept that I'm illustrating here is that basically, we're discounting future cash flows, both all the coupons and the par value to present time. This, regardless of how you do that, this should bring you the appropriate valuation for the bond today. So far, we talked about any bond, any option-free bond, regardless of embedded options. So now we can shift our discussion and start to talk about bonds with embedded options. So generally speaking, we're going to talk about 2 different bonds. One is a callable bond and the second one is a puttable bond. A callable bond, let me quickly remind you, is a bond that the issuer itself has a call option, has the option to call it back, to buy it back at a predetermined price. Now the issuer will obviously do that whenever the interest rate is about to go down. When the interest rate in the market is about to come down, the yield will come down, the price of those bonds will go up, and then the issuer will buy it back at a predetermined price, which is lower than the current price on the market, and this is how they save money. They buy something at a lower price while the actual price is higher. So the issuer will benefit from a declining interest rate. From the bondholder's point of view, this is a drawback. This is well, I shouldn't say a problem, but this is a negative point of view. This is something that will hurt the bondholders, obviously, because the issuer here is protected. So the value of a callable bond from a bondholder point of view is the value of a straight bond or a bullet bond minus the value of the call option. The call option needs to be subtracted from the value of a straight bond or a bullet bond, simply because the call option here protects the issuer, not the bondholder. With a puttable bond, it's the exact opposite. A puttable bond allows the bondholder itself to force the issuer to buy back the bond at a predetermined price. So a put option here is in fact helping the bondholder and protecting the bondholder, and it's a disadvantage to the bond issuer. So for a puttable bond, what we will do is the value of a puttable bond is the value of a straight bond, a bullet bond, a option-free bond, and to that we will add the value of a put option. A value of a put option is actually an advantage from the bondholder's point of view. So this is generally the concepts. If you remember, we already saw this kind of a chart on the left here, and we saw that the relationship between bond price on the vertical axis to bond yield or yield to maturity on the horizontal axis, in general, it is a downward sloping convex curve like that. But whenever you have a callable bond, then whenever the interest rate is going too low, sooner or later the issuer will buy back the bond, and therefore there is some sort of an asymptote over there. As you can see in the red line, it says callable bond value. So the value of a bond, of a callable bond, is converging to this line. Why is that? Simply because at some point when the yield and the interest rate will go too low, the issuer will buy back the bond. So the bond price cannot increase for too much. On the other hand, what we will add also now is the purple line on the right-hand side of this chart. As you can see, it says there puttable bond. A puttable bond protects the bond holder in this case, and it will put the asymptote on the right-hand side of this curve. In other words, if the interest rate will go up too much and the bond price will fall too much, in this case, the bond holder will force the bond issuer to buy back the bond at this predetermined price. So in general, those are the concepts that we're going to apply.